So TensorFlow is an end-to-end platform for machine learning. TensorFlow, as it heard, is a library for data flow programming. It leverages various optimization techniques to make the calculation of mathematical expressions easier and more performant. If I talk about some key features of the TensorFlows, that will be like a multi-dimensional array based numeric computation that is similar to NumPy. Efficient works with mathematical expressions involving multi-dimensional arrays. Good support of deep neural networks and machine learning concepts. GPU and CPU computing, where the same code can be executed on both architectures. High scalability of computation across machines and huge data sets. It supports model constructions, training, and export. Also, automatic differentiation can be possible through TensorFlow. So like altogether, these features actually make the TensorFlow the perfect framework for machine intelligence at a production scale. In the field of machine learning, tensors are used as representations for many applications, such as images or videos. They form the basis of TensorFlow as a machine learning framework, which also takes its name from these. So like on the other hand, the Pytorch is an open source deep learning framework that all known for flexibility and ease of use. This is enabled in part by its compatibility with the popular Python high-level programming language, favored by machine learning developers and data scientists. Pytorch is fully featured framework for building deep learning models, which is a type of machine learning that commonly used in applications like image recognition and language processing. So written in Python is relatively easy for most machine learning developers to learn and use. Pytorch is distinctive for its excellent support for GPUs and its use of reverse mode auto differentiation, which enables computation graphs to be modified on the fly. This makes it more popular choice for the fast experimentation and prototyping. So it is the work of the developers at Facebook, AI Research, and several other labs. The framework combines the efficient and flexible GPU accelerated backend libraries from Pytorch with an intuitive Python frontend that focuses on rapid prototyping, readable code, and support for the widest possible variety of deep learning models. Pytorch lets developers use the familiar imperative programming approach, but still output to graph. It was released to open source in 2017, and the Python roads have made it favorite to the machine learning developers. So in a short, if I talk about some key features of the PyTorch, that is like it's written in Python and integrated with popular Python libraries like NumPy for scientific computing, SciPy, and Kython for compiling Python to C for better performance. Because its syntax and uses are similar to Python's, PyTorch is relatively easy for Python developers to learn. It's well supported by major cloud platforms. The scripting language called Torch script is easy to use and flexible when in eager mode. This is a quick start execution mode in which operations are executed. So then it supports CPU, GPU, and parallel processing, as well as distributing training. This means that computational work can be distributed about distributed among multiple CPU and GPU cores, and training can be done as multiple GPUs on multiple machines. Then the Pytorch hub is repository of pre-trained models that can be invoked, in some cases just a single line of code. New custom components can be created of subclass of a standard Python class. Parameters can easily be shared with external toolkits like a TensorBoard, and libraries can be easily be imported. It also supports a pure C++ front-end interface that is similar to Python programmers and can be used to build high performance C++ applications. So if I right now want to talk about the comparison between these TensorFlow and the Pytorch, first I want to talk about the adaptation. Currently TensorFlow is considered as a ready to go tool by means researcher and industry professionals. The framework is well documented. If the documentation will not suffice, there are many extremely well written tutorials on the internet. We can find hundreds of implemented and trained models on GitHub. Pytorch, on the other hand, Pytorch is relatively new compared to its competitor, but it's quickly getting its momentum. Documentation and official tutorials are also fine, and Pytorch also includes several implementations of popular computer vision architectures, which are super easy to use. Then TensorFlow follows data as code, and code is data. In TensorFlow, we define graphic statically before a model can run. All communication with outer world is performed by a tf dot session object and a tf dot placeholder, which are tensors that can be substituted by external data at runtime. In Pytorch, things are way more imperative and dynamic. We can define, change the execute nodes as we go. No special session interfaces or placeholders. Overall, the framework is more tightly integrated with Python language and feels more native most of the times. Then talking about the debugging, since computation graph in Pytorch is defined as runtime, we can use our favorite Python debugging tools such as PDB, INDB, PyCharm debugger, or old trust print statements. This is not case with the TensorFlow. We have an option to use a special tool called TFDBG, which allows to evaluate TensorFlow expressions at runtime and browse all tensors and comparison in session scope. Of course, we won't be able to debug any Python code with it, so it will be necessary to use PDB separately. Then visualization. TensorFlow is awesome when it comes to visualization. These tools comes with TensorFlow, and it is very useful for debugging comparison of different training runs. TensorBoard competitor from the Pytorch side is Wisdom. It is not feature complete, but it is but a bit more convenient to use. Also, integrations with TensorBoard do exist. Also, we are free to use standard plotting tools. I mean Matplotlib and Seaborn. Then the deployment. If we start talking about the deployment of TensorFlow, is a clear winner for now. Is has TensorFlow serving, which is a framework to deploy our models on a specific gRPC server. Mobile is also supported. When we on the other hand, when we switch back to Pytorch, we may use a Flask or another alternative to code a REST API on the top of the model. This could be done with TensorFlow models as well as gRPC is not a good match for our use. However, TensorFlow serving may be a better option if performance is a concern. So like data parallelism, on the biggest features of the distinguished Pytorch from TensorFlow is declarative data parallelism. On the other hand, TensorFlow allows us to fine tune every operation to be specific device. uh, uh, so like personally I consider PyTorch to be more clear and developer friendly. Its torch.nn module gives us the ability to define reusable modules.